This is lesson 2.6, proving geometric relationships. I apologize if the sound quality is not great. I'm recording in my big open classroom and it might get a little echoey. So we're going to do a little bit of review first. We've discussed the linear pair postulate before that said if angles form a linear pair, then they're supplementary. So remember, linear pairs are angles that are adjacent and form one straight line, and I take their non-adjacent sides. So angle 1 and angle 2 are a linear pair, and because of that, they would be supplementary. Vertical angle theorem told us that vertical angles are congruent. So in this picture, vertical angles are angles across from each other. They're formed by the same lines. So angle 1 would have been congruent to angle 3, and angle 2 would have been congruent to angle 4. This third one is actually new. The right angle congruence theorem. I usually abbreviate it to right angle congruence theorem like this. And that just says all right angles are congruent. So if I know that two different angles are right angles, I can then go straight to saying that they are congruent to each other. So these will all be used in proofs. But before we use them in proofs, let's just do a little bit more practice of solving with our vertical angles and linear pairs. When we approach a problem like this, especially one with multiple variables in it, we're going to look to see if there's a relationship between the angles that have the same variable. In our problem, the two angles that have an x in them are across from each other, which means they would be congruent by the vertical angle theorem. It helps to explain what you're doing so you know why you're doing what you're doing. And the vertical angle theorem, since they're congruent, we can set 9x minus 4 equal to 8x plus 7. So if I take away 8x and add 4, I get x equals 11. And then if we had our vertical angles for the two with x in it, it makes sense that we also have vertical angles for the two with y in it. So we can have 5y equals 7y minus 34. If I take away 7y from both sides, we have negative 2y equals negative 34. And when I divide by negative 2, y would equal 17. Here's a check-in problem for you to try. You could pause if you're going to give it a shot. The answers are posted in the blank notes online. For example 2, I now still want to solve for x and y, but if I look at my vertical angles, they're different variables. So I'm going to have to approach this problem differently. There is only one angle with an x in it and one angle with a y in it. So I'm going to relate both of these angles to the 75 that exists. If I look at the angle with x in it and the angle with 75 in it, those two are a linear pair. So using the linear pair postulate, I'm going to make them supplementary. So that's going to be 75 plus 2x minus 5 equals 180. Combine our like terms. We have 2x plus 70 equals 180. Take away 70 from both sides. 2x equals 110. Divide both sides by 2, and x is 55. I can also use that same 75. There's nothing that says I can't reuse an angle. Is a linear pair with the 4y plus 25. So I can do 4y plus 25 plus the 75 equals 180. Combine my like terms. So 4y plus 100 equals 180. Take away 100. We get 4y equals 80. And dividing by 4, y equals 20. There is once again a check-in for you to try. If you'd like to pause and give it a shot, the answers are posted in the blank notes online. And now we're going to do some proofs. So we're using all of the reasons we've already learned, as well as our linear pair postulate, our vertical angle theorem, and the right angle congruence theorem if we need it. Remember, every time we do a proof, what we see as given, we put the reason is given, and the final step, final statement of every proof is what they tell us to prove. So I can fill that in right away. So I was given that angle 6 is congruent to 7, and now I'm saying that angle 6 is congruent to angle 5. I've never seen angle 5 in the proof before, so it didn't happen because of step 1. So I'm going to look at my picture, and I'm going to mark where angle 6 and angle 5 are. And I see that these are angles that are across from each other. They're vertical angles. So I can use the vertical angle theorem. Now I have 5 is congruent to 7. And 5 and 7 are not vertical angles. But if I look at the steps above, 5 was congruent to 6, and 7 was congruent to 6. So linking together the same, we could say the remainders are the congruent. So angle 5 is congruent to angle 7, and that would be the transitive property. Anytime we link, that's the transitive property. Now they're saying angle 7 is congruent to angle 8, and I've seen angle 7 before, but I've never seen angle 8 before. So in my picture, angle 7 and angle 8 are also vertical angles. So this will be another vertical angle theorem. And then it tells us our last step was found using the transitive property, and I know because both of them were congruent to angle 7 is what let me say that angle 5 was congruent to angle 8. Let's do another example together. So notice, angle 1 and angle 2 form a linear pair was given to me. Step 1 is given. And step 4 is also listed as given. So the other thing we haven't mentioned is that angle 1 is congruent to angle 3. And my statement for prove angle 3 and angle 2 are supplementary is already in step 7. So we're good there. If I know two angles form a linear pair, I can call them supplementary by the linear pair postulate. So this is one of the times where I see some words, and instead of using the definition of those words, I'm going to use those words in a different context. So I'm using the linear pair postulate. And now, to use the definition of supplementary, I know that what it means to be supplementary is that angles add to 180. So if angle 1 and angle 2 are supplementary, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We were given that angle 1 is congruent to angle 3, and now we've converted those angles into equals. And anytime we switch our symbols with the same angles or segments, we're using the definition of congruence. And now they're telling us we're going to use substitution. So the only equation I've seen is in step 3, and I now know that angle 1 and angle 3 represent the same thing. So I can substitute angle 3 in for angle 1 to my equation. So that's going to make it the measure of angle 3 plus the measure of angle 2 equals 180 degrees. And now that I know that these two angles add to 180, I can call them supplementary by the definition of supplementary. So here is a check-in problem if you would like to try it. Answers are posted online. If you'd like to pause, you can give it a shot. So now we have two additional theorems we're going to talk about. They won't be used very often, but we're just going to learn them. So the congruent supplement theorem says if two different angles, like angle 1 and angle 3, are both supplementary to the same angle, angle 2, that would have to make 1 and 3 the same. And let's see if that makes sense. If angle 2 was 130 degrees, then angle 1, which is supplementary to it, would have to be 50 degrees. And angle 3, which is supplementary to it, would also have to be 50 degrees. So that makes angle 1 and angle 3 the same. And now let's prove it. So I am given two different things here. They're listed in two different steps. So let's put angle 1 and angle 2 are supplementary, as well as angle 3 and angle 2 are supplementary. And now there are two steps where they want us to use the definition of supplementary. So I'll apply 1 to one of my givens, measure of angle 1 plus measure of angle 2 equals 180. And I'll do one for my other given, measure of angle 3 plus measure of angle 2 equals 180. And in the next step, it says they want us to use the transitive property. And if I look at the two steps above it, both equations were equal to 180. So I can now take the leftovers and say that those are equal to each other. So that would be measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. In my next line, I only have measure of angle 1 equals measure of angle 3 now. The measure of angle 2's are gone. So we've taken them away from both sides, and when you take away, that is subtraction. And we already know what should have gone in this last step because it was our proof statement. And we're switching from the two angles being equal to those two angles being congruent, and that would be the definition of congruence. So the other theorem is the congruent complements theorem, which basically does the same thing as the congruent supplements theorem. So if two angles are complementary to the same angle, then they are congruent to each other. So the proof for that is the last check-in. If you'd like to give it a try, you can. The answer is posted in the blank notes on Classroom. And that is the end of section 2.6.